Hello guys, welcome to my channel Learn the Ropes. Please like, share, subscribe for the more videos. So in the last class we have started electrostatics, electric charges and the fields chapter. So in the first basic concepts we have seen what do you mean by charge. Charge is basically it is a basic property or intrinsic property of a matter due to which it attracts or repels any other matter. This we are calling it as the basic definition of a charge, right? After that we have seen like charges repel each other, unlike charges attract each other. Suppose say there are plus q charge separated by some certain distance. These two charges repel each other with a force. Suppose say there is a minus q charge, there are the like charges, those minus q charges also repel each other. If I keep plus q and minus q charge at a certain distance, these two charges having unequal plus and minus q charges, then it will attract each other. After that we have seen the elementary particles, proton, neutron and electron. Suppose say we are taking on an atom. In the atom, nucleus is present. In the nucleus there are protons and the neutrons, where protons is a positively charged, neutron has no charge. The protons and neutrons has strongly bonded with respect to strong nuclear force. Various electron is revolving around the nucleus. This we are calling it as a structure of an atom, correct? So after that we have seen how exactly the charge is originated by the friction. When two bodies rubbed against each other, the electrons can be transferred from one body to another body. When the electron, if the body loses the electron, it has deficiency of electron. If the body gains the electron, it has excess of electrons. The one loses the electrons is a positively charged, one which gains the electron, that is the negatively charged, correct? After that we have seen how exactly when rubbed, glass rod rubbed with the silk cloth, from the from the glass rod the electrons is transferring to the silk cloth, whereas the silk cloth is getting negatively charged, where the glass rod getting the positively charged. Some different tables we have seen, the two bodies rubbed against each other, which body is getting electrons, which body losing the electrons, which body is getting the negatively charged body, which body is getting the positively charged body. Some tables we have seen, right? So after that we have seen what do you mean by conductors, what do you mean by insulator. These are the basic concepts. Conductor which allow the flow of a charge. Human body is the best conductor, right? The earth is also good conductor. Earth is containing ocean of electrons. We have seen what are the some examples of a conductor we have seen. After that, what do you mean by insulator we have seen, which does not allow the charge to flow through them. We are calling it as an insulator. The plastic, rubber, paper, all these are the some examples of the insulator. Insulators we are calling it as a dielectrics. We will see in the next chapter what do you mean by dielectrics, how exactly we are using in the capacitor and all, right? After that we have to start the next concepts, right? So now we will start with the units of charge. What are the units of a charge? What is the SI unit? What is the CGS unit? All these things we will see in terms of units of a charge. See here, we know the basic equation, that is I equals to Q divided by T, correct? No, in the 10th standard we have seen this equation, basic equation, where I is a current, Q is a charge, T is a time. When the charge is flowing through the second, then we are getting the current in the body, understood? So where Q equals to, we are giving Q equals to I into T. The SI unit of a charge we are giving, the SI unit is where I is a ampere, SI unit of a current is ampere, the SI unit of a time is second, ampere second. Simply we are calling it as a coulomb. We are calling it as a coulomb. The SI unit of a charge is coulomb. What is the dimension formula? The dimension formula of the charge. See, there is no mass, m0, l0, t is there, t1, ampere will be ampere, a1. This is the dimension formula, right? After that we have to see what is the CGS unit of a charge. CGS unit is 1 stat coulomb. The CGS unit of a charge is stat coulomb or electrostatic unit. Electrostatic unit, or simply we are taking it as a ESU, or we are taking it as a Franklin. We are calling it as a Franklin. Now it is the smallest unit of a charge. It is the smallest unit of a charge. Unit of charge. Right? So Celsius unit is stat coulomb or electrostatic unit, or simply we are calling it as a Franklin. It is the smallest unit of a charge. See here, we have seen in the units and measurement, like SI unit is a kg, Celsius unit is a gram, SI unit of a length is a meter, in the Celsius unit that is a centimeter, in the force SI unit is a Newton, in the Celsius unit it is a dyne. 1 Newton equal to how much dyne? 1 Newton is a SI unit, dyne equal to Celsius unit. 1 Newton equal to 10 to the power of 5 dyne we have seen. Now we will see what is 1 coulomb. The SI unit of 1 coulomb is how much stat unit or stat coulomb or electrostatic unit. We are taking it as a 3 into 10 to the power of 9 ESU. Just like 1 Newton equal to 10 to the power of 5 dyne. Like 1 joule of energy equal to erg we are converting now. Same we are seeing here. 1 coulomb equals to 3 into 10 to the power 9 ESU, electrostatic unit. The next point of charge is other practical units. Other practical units of a charge are 1 ampere hour. Ampere, or simply we are taking it as an ampere hour, and farad. Ampere hour and farad. 1 ampere hour is, it is consisting of 3600 coulomb. 1 ampere hour, it is consisting of 3600 coulomb, where 1 farad unit is consisting of 96,500 coulomb, where this 1 farad is a biggest unit of a charge. Biggest unit of charge. What is the smallest unit? Smallest unit is Franklin or stat coulomb or electrostatic unit. 1 coulomb consisting of, in terms of Celsius unit, that is 3 into 10 to the power of 9, where other practical units are 1 ampere hour and 1 farad, where farad is the biggest unit of a charge. It is consisting of 96,500 coulomb. Understood? So now we will see the next concept, that is gold leaf electroscope. Gold leaf electroscope. Basically it is a device. It is a device. It is device which is used to find the presence of a charge. The presence of charge and nature of a charge. Nature of charge on an object. On an object. Basically, it is an experiment we are doing. It is a setup, one setup, gold leaf electroscope. It is a device which we are using to find the presence of a charge and the nature of a charge on an object. What do I mean by this? Suppose, let's say the setup contains, this is exactly, we are setting up the experiment. The setup contains metallic disc. It is a metallic disc, and to the metallic disc we are connecting a metallic rod. This is a metallic disc. Basically it is a metallic disc, and to the metallic disc we are connecting metallic rod. It is a metallic rod. To the metallic rod we are taking 2 gold leaves. The gold leaf strip is very thin, right? The gold leaves, we are taking 2 gold leaves, we are bending in between, then we are connecting to the metallic rod. So this we are calling it as a gold leaves. 2 gold leaves we are bending from the middle, in the middle, then we are connecting to the metallic rod. This whole setup is packed in one bottle. The whole setup we are keeping we are putting in the bottle. This is, we are calling it as a cork. Basically it is made up of an insulator which does not allow the charge to the bottle. Understood? Whatever the charge we are giving to the disc, it will not go to the bottle, it will go to the rod, then finally gold leaves. Right? See how exactly we are finding the presence of a charge on the gold leaves. Whenever we are taking a body, a charged body, we are taking a charged body. Suppose say this is negatively charged body, excess of electrons are there. This is a charged body. Whenever the negative charge body we are taking and we are touching to the metallic disc. Understood? See, we are taking negatively charged body, then we are touching to the metallic disc. When we touch this electrons, number of excess of electrons having negatively charged body, when we touch to the metallic disc, these electrons from the charged body transfers to the metallic disc. Now it is connected to the metallic rod, then again it will transfer to the metallic rod. Finally, it will transfer to the gold leaves. Once the electrons comes to the gold leaves, excess of electrons comes to the gold leaves, then there will be repulsion between two gold leaves because of the same charge, same negative charge. There will be repulsion. Due to this, these gold leaves will diverge each other. There will be diversion. Because of the same amount of the electrons or same amount of the charge present on this leaf and this leaf. Understood? See here, if I put more number of electrons, if I increase the charge on the charge body, the more charge will get on the gold leaves. इसका मतलब क्या है? So the more diversion will be there in the gold leaves. Understood? If more number of charge we will put in the charge body, more number of electrons transfer, more number of electrons will accumulate in the gold leaves, then there will be more number of diversion due to same number of charge present on the other side of a gold leaf. Due to repulsion, there will be diversion. Got it? See here. So now what we are doing? Now we are taking out this charge body. We are removing the charge body now. Now this setup, which is containing metallic disc, metallic rod and the gold leaves, having negatively charged now. So now this gold leaf will diverge. Understood? Now what we are doing? We are taking positively charged body and touching to the metallic disc. This is the positively charged body. Now once you touch this positively charged body, the electrons present in this setup will transfer to the charged body. Suppose, let's say the electrons are transferring. The electrons are transferring through the charged body. Only some electrons are left. Now we are removing this charged body now. Some electrons are transferred to the positively charged body. Then we are taking out the positive charge body. Now only some electrons will be left in the metallic leaf. See here, earlier there were more excess of electrons were there. Due to that, there will be diversion. Now the electrons has got less. No. Now only some number of electrons are present compared to the previous experiment. More number of electrons. Due to this, the already divergent part, what it will do? These gold leaves will converge due to less amount of electrons. There will be conversion. So this is how exactly we are doing the experiment with respect to gold leaf electroscope. It is a device which is used to find the presence of a charge and the nature of a charge on an object. What is the nature? Suppose if I take a positive charge here, there will be conversion. Correct? No? Negative. If I take negatively charged body, already negatively charged body, then negative will transfer, there will be diversion. So if we can assume that there will be negative charge on the gold leaf. Got it? So this is how exactly we are doing the experiment of gold leaf electroscope. Right? So now this is the experiment we did with respect to find the presence of a charge and the nature of a charge on an object. Okay, so now we will see the most important concept, that is properties of a charge. Properties of charge. The first property of a charge is additivity. Additivity. See, suppose say a body has a charge with respect to 1 coulomb, 2 coulomb, 3 coulomb, 4 coulomb, then the total charge we are adding with respect to simple algebraic addition. We are not dealing with the vector physical quantities or vector addition. We are simply going with the simple algebraic addition. It is a scalar physical quantity like mass. Suppose say a body has 2 kg, another body has 3 kg, another body has 4 kg. The total mass we are adding with respect to simple algebraic addition. The same we are applying here in terms of the charge. Suppose say this body has, let's say this body has plus 2 coulomb, minus 3 coulomb, plus 6 coulomb. What is the total charge now? 6 plus 2, 8, 8 minus 3 is 5 coulomb. This is the total charge on the body. Total charge on the body is plus 5 coulomb. Understood? Suppose say, let's say this body has minus 5 coulomb, plus 3 coulomb, 1 coulomb and 2 coulomb. Plus 2 coulomb, plus 1 coulomb, plus 2 coulomb. What is the total charge now? 3 plus 1, 4, 4 plus 2, 6, 6 minus 5, this is a 1 coulomb. This is the total charge. Simple algebraic addition. With respect to simple algebraic addition, we are adding. This is a one property, that is the additivity. Understood? So now, whenever we are adding the charge now, we have to take care of the plus minus. Got it? Now, this is the first property. The second property is quantization of a charge. Quantization of charge. What do you mean by quantization? See, the smallest charge in the nature that exists is a charge of an electron. That is the smallest charge that exists in the nature. What is the charge of an electron? Minus 1.6 into 10 to the power minus 19, or a proton plus 1.6 into 10 to the power minus 19. The charge, here we are writing one important point. Charge can only exist as an integral multiple of charge of an electron. Charge of an electron. Right? Charge can only exist as an integral multiple of charge of an electron. What do you mean by this? Suppose, let's say, we have seen the experiment whenever the glass rod rubbed with the silk cloth, electrons from the glass rod transferred from glass rod to silk cloth. Whenever the electron is transferring from the glass rod to silk cloth, no, it transfers as 1 electron, 4 electron, 6 electron, 9 electron, 10 electron, like that. It can never be transferred as 1.5 electron, 2.5 electron, 3.5 electron, 2.2 electron, 1 by 2 electron, 3 by 2 electron. It will never transfer as like this. Got it? It is transferring. Electron can be transferred from one body to another body as 1 electron, 3 electron, 6 electron, 8 electron, like this. Understood? So now the charge can exist only an integral multiple of charge of an electron. This is the important equation we are getting in the quantization of charge. So now 1 electron, 2 electron, 3 electron. So n will be 1, 2, 3, 4, 5 till n number. N can never be 1.5, 2.2, 3.4, 4.5 or 1 by 2, 3 by 2, 4 by 1, like this. Sorry, 4 by 3, like this. Understood? So whenever the electron is transferring from one body to another body, the electron is transferring as 1 electron, 2 electron, 3 electron, 4 electron, like this. Suppose say, let's say Q equal to 1 electron. Understood? So what is the electron charge? 1 into 1.6 into 10 to the power minus 19. This charge will be possible charge. It is existing in the nature. Suppose if I say Q equal to 1.5 electron. Understood? Let's say 1.5 into 1.6 into 10 to the power minus 19. See, 1.5 electron will not exist. Whatever we are getting the answer from this values, no, it is not possible. It's not possible. Suppose let's say Q equal to 3 into 3 electrons are transferring. So now the value of a charge is 3 into 1.6 into 10 to the power minus 19. How much? 4.8 into 10 to the power minus 19 coulomb. No, see, this charge is possible now. Understood? 3 electrons are transferring means 3 into 1.6 into 10 to the power minus 19 coulomb charge is transferring. How much? Value 4.8 into 10 to the power minus 19. This much charge is available. इसका मतलब क्या है? This is a possible. It will exist in the nature. Understood? Suppose say Q equals to 2 electron. 2 into 1.6 into 10 to the power minus 19. 3.2 into 10 to the power minus 19 coulomb charge. This is also possible, no? Why? 2 electrons are transferring. इसका मतलब charge कितना आ रहा है? 3.2 into 10 to the power minus 90 coulomb. This is one of the most important property we will come across in the electric charges and fields. That is the quantization property. Charge can exist only in an integral multiple of a charge of an electron. Whenever the electron is transferring from one body to another body, it is transferring as a 1 electron, 2 electron, 3 electron, 4 electron. It is not transferring as a 1.2, 3.2, 3 by 2, 2 by 0.5, like this. Whatever the value, we are getting the point value as a n value. It is not existing in the nature. Got it? So we will see some of the examples in the quantization of a charge. Suppose, let's say we are taking example 1. First one, how many number of protons are there? How many number of protons constitutes in 1 coulomb charge. What do you mean by this? Here, how many number of protons constitutes in 1 coulomb charge? A body is there. In the body, excess of protons are there. इसका मतलब charge कितना है उसका? 1 coulomb charge है. Understood? The body is having 1 coulomb charge. इसका मतलब how many number of protons are there in that body? They are asking. So what is the equation? Q equal to N into E. What is the charge in the body? 1 coulomb. What is N? That we need to find out now. How many protons? E 1.6 into 10 to the power minus 19. So N equals to, we are getting the value 6.25 10 to the power minus 19 protons. But N can never be point, no? We are getting the point value. See, it acts as 0, 0, 0, 0, 0, 0. See, it will be possible, no? So N equal to 625, some zeros. So it exists in the nature. This 1 coulomb charge exists in the nature. Got it? So how many protons are there? This much protons are there. 0, 0, 0, 0 protons are there. Understood? Let's say second example. If 1 million electrons are removed from the body, what is the charge on the body? What do I mean by this? What we are doing? 1 million electrons we are removing from the body. इसका मतलब body क्या charge होता है? Positively charged. It is losing the electrons now. How many electrons? 1 million electrons. Understood? That charge we need to find out. So 1 million मतलब कितना? 10 lakh no? 1 million equal to 10 to the power of 6. So what is the charge on the body? N into E. What is N? 10 to the power of 6. What is electron? 1.6 into 10 to the power minus 19. This much electrons we are removing. 10 to the power of 6. इसका मतलब body has been positively charged. Now it will be, the charge on the body will be 1.6 into 10 to the power minus 13 coulomb. This charge will exist in the nature. Got it? So this charge will exist in the nature. Suppose, let's say example 3. Suppose if I ask one 3.2 into 10 to the power minus 19 coulomb, this charge will exist or not in the nature. We have to find it. See here, this is a charge Q. Now we need to find out this charge will exist or not in the nature. To find out, we have to get n value in terms of 1, 2, 3, 4. It can never be 1.2, 1.5. If we are getting 1.2, 1.5, 2.5, this charge will not exist. If we are getting like even values, then we can say that this charge will exist. To find out, we have the equation Q equal to N into E. Correct no? So what is the charge? Charge is 3.2 into 10 to the power minus 19. Correct? Equals to N. E will be 1.6 into 10 to the power minus 19. So N equal to 3.2 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19. Minus 19 gets cancelled. 1.6, 3.2 will be 2. इसका मतलब we are getting n equal to 2. इसका मतलब we are getting even value. So this charge will exist in the nature. Suppose let's say 3.2 into 10 to the power minus 18. Now tell me this charge will exist or not. So Q equal to 3.2 into 10 to the power minus 18 divided by 1.6 into 10 to the power minus 19 equals to n. So this will be 2. This is 2. Minus 19 plus 19. Correct no? Into 10 to the power 1. इसका मतलब n equal to 20 आ रहा है. इसका मतलब this charge will also exist in the nature. Suppose if I ask, let's say if I ask, I will do here the third one, 3.2 into 10 to the power minus 20. This charge will exist or not? Say n equal to 3.2 into 10 to the power minus 20 divided by 1.6 into 10 to the power minus 19. This will be 2. 10 to the power minus 19 goes up, it will be 10 to the power plus 19. So minus 20 plus 19 will be minus 1. 2 into 10 to the power minus 1. So n we are getting 2 into 10 to the power minus 9, minus 1. This charge will exist or not? Tell me. How much we are getting? 0.2 we are getting? No. इसका मतलब this charge will not exist in the nature. Got it? So this we are calling it as a quantization property. This is one of the important property in the charge. Charge can exist only in the integral multiple of charge of an electron. This is the quantization property. Now, the third property, we have seen that already in the origin of a charge due to friction. Conservation of a charge, right? In the conservation of a charge, third one, conservation of charge, right? So in the conservation of a charge, we are writing the first important point, total charge in an isolated system. In an isolated system remains constant. Remains constant. Second point we are writing, charge can neither be created nor destroyed. It can only be transferred from one body to another body. This is one of the most important properties. Here, whenever we are rubbing a glass rod to the silk cloth, no charge can be transferred, electrons can be transferred. Whatever the total charge we have before rubbing, the same charge we are getting after rubbing. इसका मतलब क्या है? The total charge remains constant. That is an isolated system. What I mean by isolated system? The isolated system we are calling it as a no charge allowed to enter the system or leave from the system. This system we are calling it as an isolated system. Suppose let's say this is an isolated system. Let's say this is the isolated system. Isolated system मतलब क्या है? No charge allowed to enter the system or leave from the system. This system we are calling it as a isolated system. Suppose let's say this is a plus 2 coulomb, plus 4 coulomb, plus 2 coulomb and minus 4 coulomb. This isolated system has this much charge in it. What is the total charge here? Plus 2 plus 2 4, 4 minus 4 0, plus 4 4 coulomb. Total charge in the body is plus 4 coulomb charge. Suppose let's say this isolated system, if we see after some years, if I see the same isolated system, I may look it as plus 1 coulomb, minus 2 coulomb, plus 4 coulomb. The same system we are seeing after some years, it will be like plus 1 coulomb, minus 2 coulomb, plus 4 coulomb. What is the total charge? Total charge still 4 coulomb. Individual charges may differ inside the system, but the total charge remains constant. This important property we are calling it as a conservation property. We are calling it as a conservation of a charge. Whatever the total charge before, the same charge we have after some years. Understood? Charge neither be created nor be destroyed. It can only be transferred from one body to another body. What do you mean by this? Suppose we have seen already this. Let's say this is a glass rod. It is the glass rod. Let's say it is in the neutral condition. 4 protons, 4 electrons. Let's say we are taking silk cloth. Again, this silk cloth is having plus 4. This is the silk cloth. Let's say the total charge will be 8 protons, 8 electrons. This is before rubbing. It is a before rubbing. If I rub the glass rod against each other silk cloth, then electrons from the glass rod transferred to the silk cloth. Earlier it is having 4 protons, 4 electrons. Now the 4 electrons are transferred from the glass rod to silk cloth. Matlab minus 4 electrons are transferred. How many total charge are there? 8 protons, again 8 electrons. See, whatever the total charge we have before rubbing, the same charge is containing after rubbing. No, इसका मतलब क्या है? Charge can neither be created nor be destroyed. It can only be transferred from one body to another body. This property we are calling it as a conservation of charge. Understood? Okay. So then now next property, the fourth property, charge is always associated with mass. What do you mean by this? Charge is always associated with the mass. Here, whenever the electron is transferring from one body to another body, no, it is having the mass. How much mass? 9.1 into 10 to the power minus 31. If one electron is transferring from one body to another body, its mass is also transferring. If 2 electrons are transferring, 2 into 9.1 into 10 to the power minus 31 kg mass is transferring. This we are calling it as a charge is always associated with the mass. Suppose let's say the body which loses the electrons, loses the electrons, its mass decreases, correct? No, its mass decreases. Suppose, let's say, see, here the electrons mass and the protons mass were there, correct? No, 4 into 9.1 into 10 to the power minus 31. If the electrons are transferring to this body, the mass will decrease in the body. No, it lose the electrons. इसका मतलब mass is decreasing in the body, in the glass rod, its mass decreases. The next one, the body which gains the electrons, its mass increases. Its mass increases. See here, in the silk cloth, it is gaining the electrons. There is the excess of electrons are there. No, इसका मतलब 4 into 9.1 into 10 to the power minus 31 kg has been gained by the silk cloth. The body which gains the electrons, its mass also increases. Suppose, let's say, this is a neutral body. It is a neutral body which is having m mass, right? Suppose, say, if the body loses the electrons, इसका मतलब positively charged body, this is positively charged body, its mass is decreasing, m minus delta m. Suppose, say, this body gains the electrons, this will be negatively charged body, its mass increases as m plus delta m. This is one of the property of a charge. Charge is always associated with the mass. See, the mass can exist without charge, but charge will never exist without the mass. Whenever there is a charge, there is a mass. Understood? The third point we can write as charge can never exist without mass. Various mass can exist without the charge. Clear? So this is the fourth property. Charge is always associated with the mass. The next property, the fifth property is charge is invariant. Charge is invariant. What do you mean by this? See, mass is variant. इसका मतलब क्या है? Whenever a mass is moving with the velocity, we are comparing with the speed of a light. Whenever the mass is moving, it varies with respect to speed of a light. But whenever the charge is moving, it is not changing its value. What do you mean by this? Suppose we are giving one important equation, m equal to m naught divided by under root 1 minus v square divided by c square, where m naught is a real mass, where c is the speed of a light, v is the velocity of a mass, velocity of a body. Whenever this mass is moving comparably with the speed of a light, this mass will change. What do you mean by this? Suppose, let's say, c value is 3 into 10 to the power of 8. If you are moving with the 3 into 10 to the power of 8 meter per second, this will get cancelled out. 1 minus 1 will be 0. It will be infinite. Your mass will become infinite. Suppose, say, you were having 60 kg. If you are moving with the speed of a light, your mass will become infinite. But charge is not related with the speed. Understood? Charge will not change whenever it is a invariant. Understood? This is the fifth property. Next, we will see when the charge is at rest condition, what exactly it is producing. Whenever the charge is moving, what exactly it is producing. See, we have seen the electrostatic part as a charge is at rest condition. Whenever the charge is at rest condition, it gives an electric field surrounded by it. What do I mean by? Suppose, let's say, whenever the charge is at rest condition, it is at rest condition, it produces electric field. field surrounded by it. Whenever it is moving, whenever the charge is moving with constant velocity, constant velocity, इसका मतलब क्या है? Acceleration equal to zero. There is no change in the velocity. Acceleration is zero. So change in the kinetic energy will be zero. It produces electric field and magnetic field as well. We will see in the moving charges and magnetism. Whenever the charge is moving with the constant velocity, if there is no acceleration, then it produces electric field as well as magnetic field. If it is moving with acceleration, then it radiates energy. Acceleration, it radiates energy. It produces electric field, magnetic field, and also electromagnetic wave. It produces the electromagnetic wave. So whenever the charge is at rest condition, it produces only electric field. We will see what do you mean by electric field. What is the equation of electric field? If it is moving with the constant velocity, if there is no acceleration, whenever the charge is moving with the constant velocity, it produces electric field as well as magnetic field surrounded by it. Whenever the charge is moving with the acceleration, then it produces the electric field, magnetic field, and electromagnetic field. The last one, suppose say, let's say we are taking, let's say this is solid or hollow conducting body. We'll explain that later. You have to remember these cases. Suppose say, let's say it is in the neutral condition. It is a conducting body. Neutral condition means number of protons equal to number of electrons. If I inject a charge inside this hollow or solid conducting body, suppose say positive charge we are injecting in the body. Whatever the excess of charge we are injecting in the solid or a hollow conducting body, those excess of charge will come to the surface and resides on the surface of the solid or hollow conducting body. If I take a solid non-conducting body, we will explain this later. Just you need to remember what is the case. If I inject the positive charge in the solid non-conducting body, then the charge will reside inside the volume of the conductor. These cases we need to remember. We will explain this later after electric field. How exactly we are getting the charge with respect to solid conducting or hollow conducting, solid non-conducting body. Got it? So in today's class we have seen what is the units, SI unit, what is the CGS unit of a charge, what is the smallest unit of a charge, what is the biggest unit of a charge, what do you mean by gold leaf electroscope, what is how exactly we are finding the presence of a charge and nature of a charge on an object. After that we have seen the most important properties, additivity of a charge, quantization property, we have seen some examples. After that, conservation of a charge is always associated with the mass, charge is invariant. Next, whenever it is at rest, moving with the constant velocity, moving the acceleration, how it is producing. Then the last concept, solid conducting body, solid non-conducting body. Right? In the next class we will see some more things. Thank you.